93, page 93. Would you rather turn to page 93 or would you rather not know this part for the test? Okay. So let's remind ourselves there are two steps in the synthesis of protein. What does the word synthesis mean? Making. Okay, so protein synthesis is protein making or making protein. What are the two steps called? Step 1 is called transcription. And step 2 is called translation. Where does transcription take place? It happens in the nucleus. Where does translation take place? In the cytoplasm. What are we making during transcription? During transcription, we are making mRNA. What are we making during translation? We're making the protein. The two steps together are called protein synthesis. Anything new here? No, this is stuff we had before. So these are just pictures so you can imagine it better. Transcription, we take our two-stranded DNA and we make a one-stranded copy, the RNA, and then translation, we translate the RNA code into the amino acid sequence. You can see here, transcription takes place in the nucleus and translation takes place in the cytoplasm in the ribosome. So far, so good? Okay. This, you don't need to know the details here, but some people are like, they're confused. They don't know how this happens. What happens is there is an enzyme that actually unwinds a section of the DNA helix. Helicase, yes, you are right. You are correct. I'm going to write it down, but you do not need to know this, not even enriched. I'm not going to put it anywhere. Helicase. Okay, and then free-floating nucleotides. So in the nucleus, there's free-floating RNA nucleotides. They attach themselves to the RNA. So you can see we've made some of the messenger RNA chain here, right? Some of the messenger RNA chain there, but there are now RNA nucleotides coming in, and this enzyme also helps those nucleotides attach. I could be wrong about that. Maybe there's a second enzyme. I don't remember because I haven't taught this at anything further than a grade 9 level in 30 years. So I can't remember the details of the enzymes. But if you take grade 12, you'll learn about them. Okay, so they come in and you get this copy and then everything detaches. Yep, that's it. The RNA nucleotides are the monomers and the mRNA molecule is the polymer. You don't need to know any of that detail. That's just kind of there so you kind of get how it happens. So here we are, we've got the DNA. It unravels a little bit, it untwists, and we make the mRNA. So it untwists, and we get the mRNA, then the mRNA goes out through the nuclear pores, and it goes into the ribosome, and we have these amino acids here, and then we have translation. Translation is sort of skimmed over there. So we're going to take a little closer look at translation. In order to do translation, you need a ribosome. The ribosome is made of two subunits. It's made of a large subunit and a small subunit, and the two together make the ribosome. What is the ribosome mostly made of? Made mostly of rRNA. Perfect. So we need the ribosome, we need the mRNA, and we need the tRNA. All three of those types of RNA are necessary for protein synthesis, for the translation part. We also need amino acids. So you need four things. You need 1, ribosomes, 2, mRNA, 3, tRNA, and 4, amino acids. If you are lacking any of those, you cannot do translation. You cannot assemble the amino acids. Now, where are the ribosomes made? Ribosomes are made in the nucleolus. And you can see here we've got the cell, then we've got the nucleus, and then we have the nucleolus. So it's like big, smaller, smaller. Cell, nucleus, nucleolus. Do it with me. Cell. What comes next? Nucleus, and then nucleolus. And what happens in the nucleolus? We make the ribosomes. And the ribosomes are actually very small as well. So how do they get out of the nucleus? Through the nuclear pores. Yes? And you can see that we've got some transcription taking place. Over here, we've got that enzyme assembling that, and the mRNA also goes out through the nuclear pores. And then we get translation. And again, this translation looks pretty undetailed, so we're going to zoom in on that a little bit more. So the mRNA is read 3 letters at a time. What do we call those 3 letters in the mRNA? The 3 letters on the mRNA are called a codon. So this is a codon. Codon, 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 codon. And each codon corresponds to a particular amino acid. So if you have an AUG, that corresponds to methionine. You don't need to know that name. If you have an ACG codon, that corresponds to threonine. If you have a GUA codon, that corresponds to valine, and so on and so forth. Every 3-letter code gives you a different amino acid. You don't need to know any of those names. You don't need to know which one matches with which one. You just need to know that a specific codon gives a specific amino acid. So far, so good? Okay. How does the transfer RNA come in? Well, first of all, let's take a look at what transfer RNA looks like. It is a sequence of A's and C's and U's and G's. And some of them stick to each other Okay, you don't need to know the details of this structure, but if you're interested, they stick to each other by hydrogen bonds, just like the DNA sticks to the DNA by hydrogen bonds. Okay, and they form this T-like structure. And at the bottom of the T-like structure, there are 3 letters, and that is the anticodon. The anticodon is complementary to the codon. And for every anticodon, they have a specific amino acid. So if we have the anticodon UAC, then that will grab a methionine. If you have the anticodon UGC, that will grab a threonine. If you have an anticodon CAU, that will grab a valine. Okay, so you don't need to know those details. You just need to know that for every specific anticodon, there is a matching specific amino acid that it will grab. So in the cytoplasm, here comes the mRNA. It goes right in between the large subunit and the small subunit. So that's happening at the same time as the mRNA goes in there. These empty tRNAs, this is an empty tRNA. It grabs an amino acid. Not just any old amino acid, it grabs the correct amino acid. So now you've got tRNAs that have amino acids attached to them. And then we got this lovely little picture here that kind of shows us what goes on inside the ribosome. Are you going to have to draw this? No. Might you have to label this? Yes. Be able to label. I like that because it rhymes. Makes me happy. You do not need to know peptide bond. That's enriched. Okay? You should know amino acid. Polypeptide is enriched. If you just want to call it a protein, that's okay. You should be able to label the tRNA. You should be able to label the anticodon, which is this part here. You should be able to, now sometimes people get confused. You know, there will be an arrow pointing here, and sometimes people will label this sugar phosphate backbone. But the better answer is mRNA. And I think if I put it on the test, I usually go the whole strip. Long strip. Yes, and you would label that is mRNA. You should know that the 3-letter code on the mRNA is called a codon. And then I kind of liked this diagram because it shows that as one tRNA comes in, You can see it coming in here. Yes, as it comes in to match up. Another one gets kicked out. And you'll notice the one that gets kicked out, does it have an amino acid on it? No, the amino acid is gone. So this one will come in, you'll form a bond there. This one will go over and then it'll get kicked out, and so on and so on and so on and so on. Okay? Did that help to make translation more understandable? Good. I went looking for pictures. So anyway, the polypeptide, this is called the polypeptide as unfolded, polypeptide. And then folded up, it is the protein. And then finally, we just have a little summary here. It shows the nucleus, it shows the transcription, and it shows the translation. Is good? Okay, excellent. And then there's a diagram here that you can label if you want to, right? That'll give you a little practice for that. Yeah? Alrighty. So your homework, 55, 67 to 68, 69 to 77. And then tomorrow, we'll just do adding on to your cheat sheet review. If there's anything else that I feel like we've missed, we can just do that. Don't throw paper. Thank you. Stop recording.